Okay, welcome to video 8 here. We're going to be talking about linear inequality application problems. So this is similar to what we've just done in the previous video, but only this time we have inequalities. So the procedure for application word problems is still going to be very similar. We're going to read the problem carefully and highlight important keywords or information. Then you're going to determine if the word problem represents a linear inequality. So we have less than, greater than, less than or equal to, greater than or equal to signs, meaning that we have multiple solutions and they're all shown in the shading area, so we need to have some shading. Then we determine the correct axes for the graph depending on the domain and range. So it's an L-shaped if we have no negative x's allowed in the domain or no negative y's for both of those things. And then it would be all four quadrants if all x's are allowed or all domains, and same thing with the ranges because we include the negatives in those. So in order to solve these, we're going to recall the keywords for inequalities. When we have is less than, fewer than, shorter than, or smaller than, we want to use less than. When we have at most, maximum, or is no more than, that means that it is less than or equal to. And when we have the words is more than, greater than, longer than, or larger than, that means that it's going to be the greater than sign. And the words at least, minimum, or is no less than means that it's going to be greater than or equal to. And remember that these are only some of the words that we could use. There might be other ones, but you just have to always consider what is less than or greater than. What part of the problem should that be facing? Okay, so let's try a problem together. Okay, so we have this problem. Olivia is going to a Halloween party and needs to bring an appetizer. She only has $50 to spend, so that means that she can't spend more than that. She can only spend what she has. And she decides to make a cheese and grape tray. So she's buying cheese and grape. 1 pound of grapes costs $3 and cheese costs $5 per pound. We want an inequality, so they're telling us that it's an inequality to represent the amount of cheese and grapes Olivia can take in relation to the amount of money that she has to spend. Well, we know that it has to be she can only spend $50. She could spend all 50 or she can spend less, but she can't spend more than that. So the amount that she spends has to be less than or equal to 50. So I wrote that as 50 is greater than or equal to. And what is it greater than or equal to? Well, what we're spending. So if it's grapes are $3, and I can see on my graph below the grapes are on the x-axis, so that means that x needs to be the number of grapes. So we write that as 3x because it's $3 per pound of grape, and I don't know how many pounds of grapes I'm buying. Plus, I'm also buying cheese, which costs $5 a pound, so 5y for the amount of pounds of cheese that I have. Okay, so that's my inequality. So that's part A. And then part B says that I need to use the grid to sketch a graph. So basically, I need to graph this of the inequality, and we need to state one possible amount of cheese and grapes that she could buy. So in order to be able to graph this, I have to put it in y equals. So we do that just like we always do. I'm going to first just rewrite the inequality. 50 is greater than or equal to 3x plus 5y. Well, I need y by itself, so I'm going to subtract 3x first. And I do that to both sides, and when I do that, I can't combine the like terms on the left-hand side, so I just write them side by side. So then I have the negative 3x plus 50 equals 5y. Well, now I need to get the y by itself, so that means I need to divide everything by 5. So you can either do pretzel method on the left-hand side here, or we can just divide each thing by the 5. When I do that, I get negative 3 over 5x plus 10 is greater than or equal to y. And remember that we could also rewrite this as y is less than or equal to 10 plus negative 3 over 5x. So it doesn't matter which way as long as the side that's less is going to the y. Okay, so now I can graph this in one of two ways. I can either go up to the y-intercept and use slope to graph it, or I can put this in y equals. It can't tell me the shading, but it can give me the points off of the table. So when I do that, I get my points, and be careful, this kind of moved up for some reason, but remember the x should always be in line with the fraction bar or in the numerator, not in the denominator. But I do have my nice points here, so now I can go to my graph and plot those points on the graph. So that's where we're going to leave it, and that's where you'll pick up, is plotting these points, connecting with a solid line because it's included, and then determining your shading with a test point. Just remember that we have an L-shaped graph, so we should not go into the negatives. Okay, that's it for this video. Have a good evening.